settle in and let your breathing slow, because tonight you are lying on warm stone that only pretends to be still. The air is dry, almost weightless, and somewhere far off, a low rumble rolls through the dark. Maybe thunder, maybe the earth quietly adjusting its seams. You think this is solid ground, permanent, finished. But here, in the Afar Triangle, the planet is still under construction and demolition at the same time. With the Sleepless Geographer, you will move gently through cracks, salt flats, soft lava light, and future coastlines, following simple clues, one calm landscape at a time, while the world reshapes itself in slow motion. The first clue is temperature. Not the kind you check on a screen, but the kind you feel through your ribs. The rock beneath you holds heat the way cast iron does, patient and stubborn. And it holds it because it is not just rock, it is a lid. Under the Afar Triangle, the Earth is closer than it should be. Not closer in distance, exactly. Closer in behavior. The ground here is the crust, yes, but the crust is thinner than your instincts want it to be. The deep heat, the melt, the pressure, the slow churn of the mantle, they are not politely far away. They are near enough to leave fingerprints on the surface. So when that low rumble drifts across the night, you learn a new habit. You stop assuming it needs weather to exist. You are in a place where the planet is quietly practicing separation. The Afar Triangle sits in the northeastern corner of Africa, where the land looks like it has been left out in the sun too long. The colors are faded, tans and browns, black lava, white salt, the occasional harsh green near water that tastes like minerals, and disappointment. But the real story is not the surface color. The real story is the way the ground behaves, like a tabletop that has started to warp. Here, 3 big pieces of the Earth's outer shell meet, and they are not meeting in a friendly way. Imagine 3 slow shopping carts in a parking lot, barely moving, but all pointed away from each other. They do not crash, they do not race, they simply drift. And because they drift, the asphalt between them begins to crack. One piece is the Nubian plate, carrying much of Africa like a tired waiter. Another is the Somalian plate, pulling to the southeast. And then there is the Arabian plate, sliding away to the northeast, toward the Red Sea. The names sound neat and tidy. The reality is not, because when plates pull apart, the land between them does not stay politely level. It stretches, it thins, it sags, and it splits. It becomes a long, low wound, a rift. And the Afar Triangle is where that rift is not just an idea on a map. It is a physical sensation, a geography you can lie on. You think you are resting on a flat desert floor, but the floor is actually a shallow bowl, a place that has been dropping as the crust stretches. In some areas, you are below sea level already, even though the sea is not here yet. Congratulations, you found a future coastline, and it is currently pretending to be a desert. This is what makes the Afar Triangle feel so strange. It is land that behaves like the beginning of an ocean. The night air is still, but the ground keeps its own schedule. Every so often, somewhere out in the dark, there is a small earthquake. Not the dramatic kind that throws furniture around, more like the planet clearing its throat. A soft jolt, a tiny rearrangement, a reminder that the stone you are lying on is under tension like fabric being pulled at three corners. If you could see the rift the way the Earth sees it, you would not see a single crack. You would see a whole system of them, long fractures running like dry lightning across the landscape, parallel faults, step by step, where blocks of crust have dropped down, tilted slabs, sunken corridors. Rift valleys are not carved by water first. They are made by stretching. The land is pulled thin, and gravity does the rest, lowering the middle like a sagging shelf. In daylight, these rifts can look gentle from a distance. They can look like wide valleys, like places where a river might peacefully wander. But the valley is not peaceful. It is the shape of failure, slow failure, measured in millimeters and small surprises. And because it is slow, humans try to live with it. They build towns and roads on it. They graze animals across it. They drill wells. They make plans. The Afar people have lived in this region for generations, adapting to heat and dryness and salt, moving with the seasons in the water that exists only when it decides to. Camels and goats learn the same lesson. Do not argue with the landscape. You will lose. Instead, you listen. You follow the sparse gleam. You watch the sky. You remember where water hides. In the Afar Triangle, you also learn to watch the ground, because it sometimes opens. Not like a movie, more like a zipper, slowly unfastening. In the early 2000s, a section of this region near Dabahu experienced a sudden rifting event. The crust split along a fissure, and the ground moved by meters in days. The Earth did in a week what it often does in centuries. There was magma involved, of course, because when you pull the crust apart, the pressure drops and the deep melt rises to fill the space. It is not personal. It is just physics, but it feels personal when you are standing there. Even now, lying on warm stone, you can imagine that event not as news footage, but as a sensation. The faint tremble first, like a distant truck. Then a deeper vibration, as if the bedrock has a heartbeat. Then the soft tearing sound of rock failing, something you do not expect stone to do. And after that, quiet again. The desert resumes its stillness, like nothing happened, except the crack remains. The danger here is not constant chaos. It is the way normal life sits on top of unfinished geology. You can go days with nothing but heat, wind, and the dull shine of stars. And then, without warning, a new fissure can appear across a road. A salt flat can shift. A vent can open, releasing gases that have been trapped since before your species had a name. The ground is calm until it is not. And once you accept that the ground can move, you start to notice the long, quiet cracks that tell you where it's trying to pull apart. Some cracks are wide enough to step across. Others are hairline fractures that only show when the light is low and sideways, when shadows fill them like ink. In places, the land has broken into a stair-step pattern, blocks dropping down along faults. You can stand on one level and look at another, only a few meters lower, and realize you are looking at the architecture of stretching. The rocks here tell the story too, if you know what you are touching. Basalt is common, dark, volcanic rock, cooled from lava that once moved like thick syrup. It can form smooth plains or jagged piles or ropey textures that look soft until you kneel down and remember that beauty is not the same as comfort. Basalt belongs in places where the crust is thin, where melt rises easily, where the earth is allowed to bleed. And here, the earth bleeds often, though not always loudly. You are lying in the kind of landscape that geologists love and engineers quietly dread, because the features are young and the processes are active, and the ground does not promise to stay where you left it. The map is always becoming slightly incorrect. If you drift your attention outward, you can sense the scale of it. The rift does not belong only to this triangle. It is part of the East African Rift System, a long tear that runs down the continent like a seam coming undone. The Afar Triangle is simply the place where the seam meets the ocean seams, where the Red Sea Rift and the Gulf of Aden Rift connect. It is a triple junction, which sounds like a boring traffic interchange, but in geology, it is a rare kind of symmetry, a point where three rifts spread outward like the letter Y. It is the planet trying to divide one landmass into two, and then continuing until water fills the gap. A future ocean begins with a crack, and in Afar, you are at the beginning. So yes, people call it dangerous, and they are not wrong. It is hot enough to erase your energy. It is remote enough to make rescue feel like a rumor. It is geologically restless. But the most dangerous part is the way it looks manageable at night. The stars are steady. The horizon is flat. The air cools just enough to make you forget the day. Then, the ground remembers what it is doing. You can feel that restlessness most clearly in the way the surface is shaped. Rift topography is not a single canyon. It is a broad sag, cut by fractures, dotted with volcanic cones and lava fields, and filled in places with sediments and salts. It is a workshop floor scattered with materials from different stages of construction. In some spots, the land is so low that it collects whatever water arrives, but because the climate is so dry, that water does not stay. It evaporates, leaving minerals behind. Salt becomes the memory of a lake. In other spots, volcanic ridges rise like dark spines, places where magma has pushed up and hardened, building new crust in thin, repeated layers. You can walk on these ridges and feel like you are on the back of something alive, something that keeps inhaling from below. The stretching does not happen smoothly. It happens in episodes. The crust accumulates strain, like you bending a plastic ruler. For a while, nothing seems to change. Then, suddenly, it snaps a little. Earthquakes, fissures, small eruptions, then a return to quiet. That cycle is part of what makes this place unsettling in a calm way. The landscape is not trying to scare you. It is simply refusing to be final. And you begin to understand why this is one of the most important places on Earth to study. Not because it is pretty, though it can be in a harsh way. Not because it is comfortable, because it is not, but because it is an open book. Here, you can watch continents break. Most of the time, continental breakup is something you infer from ancient rocks and ocean basins that already exist. It is like studying a crime scene long after the event. But in Afar, the event is still underway. The clues are fresh. The fractures are new. The heat is still close. The future coastline is already being drafted. And where the land thins and splits, heat gets closer to the surface. So the next thing you feel is the planet's warmth leaking out. You do not need to see a volcano to know it is there. You can feel it in the way the ground holds heat long after sunset. You can smell it sometimes, faint sulfur like a struck match. that never fully goes away. You can see it in the way certain rocks look, newly born, sharp-edged and black, as if they have not had time to be sanded down by weather. Volcanoes in a rift are not always the tall, perfect cones you imagine from postcards. Here, volcanic activity can be spread out, low and wide, fed by fissures rather than a single dramatic vent. The Earth does not always bother with theater. Sometimes it just opens a crack and lets the melt out. Still, there are names that carry weight in this region. Eruptions is one of them. A shield volcano, broad and low, known for a persistent lava lake. A lava lake sounds like fantasy until you remember it is simply molten rock, exposed to air, glowing because it is hot enough to shine. It is the Earth's interior, showing itself without shame. If you approach such a place, you learn the difference between distance beautiful and distance safe. From far away, the glow is almost comforting, a hearth in the desert night. Up close, it is a reminder that your body is mostly water, and the planet does not care about that. Lava can move slowly, which is part of its trick. Slow things look less dangerous. A slow wave seems gentle until it reaches you. Lava flows, especially basaltic ones, can creep, fold, and ooze, forming smooth ropes and crusted surfaces that crack open to reveal orange heat beneath. It is not fast like an explosion. It is patient like a decision. And that patience makes it oddly terrifying. You cannot outrun every lava flow, but often you do not need to. The real threat is what lava does to everything in its path. It burns, it smothers, it covers, it erases, it turns roads into memory, it turns homes into outlines. Congratulations, you have discovered that the planet can remodel without permits. Volcanoes exist here because the crust is thinning. When the crust stretches, pressure decreases in the mantle below. That reduction in pressure allows rock to melt, a process called decompression melting. It is not that the Earth suddenly got hotter. It is that the lid got lighter. Magma rises because it is buoyant compared to the solid rock around it, and because cracks and weaknesses give it pathways. Sometimes it stalls underground, forming chambers and sills. Sometimes it forces its way upward as a dike, a vertical sheet of magma that wedges the crust apart like a crowbar. That is one of the quiet truths of rifting. Magma does not just erupt, it also helps pull the continent apart. In some rifting episodes, magma intrudes without much reaching the surface. The ground may crack and shift, and yet the lava never shows itself. The event is underground, expressed only as earthquakes and deformation. You can walk across the surface afterward and see fissures, offsets, and new fractures, and the magma that caused them remains hidden, cooling slowly in the dark. It is like the planet wrote a letter and did not sign it. But when magma does reach the surface, the landscape changes quickly, even if the flow itself is slow. Fresh lava creates new land. It resets the surface, it sterilizes, then later becomes soil, but only after a long period of being stubborn rock that resists weather. If you stand near a young lava field, you feel how sharp the world can be. The rocks are jagged, broken, full of edges that tear at boots and tires. It is not a place that welcomes bare skin. Older landscapes soften with time. This one is still rude, and yet, in the night, even the harshness becomes quiet. The glow on the horizon might be a lava lake, or it might be a distant town light bouncing off dust. Either way, it reminds you that heat is part of the region's normal. The Afar Triangle is not only stretched, it is baked. The climate is arid, and some parts are among the hottest inhabited places on Earth. Daytime heat can be severe, the kind that makes movement feel expensive. Night brings relief, but not always coolness, more like a reduction in punishment. It is here that you realize something important. The planet does not separate its processes neatly. Tectonics influences volcanism. Volcanism influences the shape of the land. The shape of the land influences where water collects. Water influences salt and soil. Soil influences life. Life influences where humans settle. Humans build things. The earth cracks them. It is all one system, one slow machine. And the machine has rhythms. Magma rises, pressure builds, the land opens, and the surface rearranges itself. Then the flow cools. The cracks quiet down. The desert resumes its wide silence. You could almost believe nothing is happening. But below you, the plates continue their millimeter drift, like a calendar page turning too slowly to notice. It is calming in a bleak way, because if the Earth can keep doing this for millions of years without panic, maybe you can stop treating every small worry like a crisis. After the heat, you start looking for water, because even in harsh places, it shows up in strange, stubborn ways. Water does not arrive here like a polite guest, with luggage and a schedule. It arrives like a rumor, thin, occasional, and hard to trust. One day, a shallow basin holds a mirror of sky. A week later, it is gone, and the only proof is a bright crust left behind on the mud, like the region is trying to fossilize its own weather. You walk toward what looks like a wet sheen in the distance. The air shimmers above it, and your eyes do that tired desert thing, turning heat into imagination. You think it is a lake. Wrong. It is often a salt flat, a pan so flat and bright it can impersonate water from kilometers away. A perfect little deception, courtesy of evaporation. In the Afar Triangle, basins are traps. Not traps for animals, traps for minerals. Water flows in when it can, from rare rains, from seasonal rivers, from distant highlands that catch clouds more often. It collects in low places because gravity is the most reliable employee on Earth. Then the sun clocks in and starts removing the water molecule by molecule, leaving everything else behind. The process is almost insultingly simple. Water arrives. Water leaves as vapor. Salt stays. Repeat this long enough, and you get a landscape that looks like snow, but burns like spilled chemicals if you treat it casually. These are closed basins, meaning there is no easy outlet to the sea. No river carries the dissolved minerals away. So the chemistry concentrates. Each cycle of flooding and drying is a gentle distillation, and the residue becomes thicker, whiter, and more elaborate. If you kneel and touch the surface, it can feel like a crust on cooling bread. Thin in places, thicker in others, sometimes strong enough to hold your weight, sometimes not. Congratulations, you have found a floor that may or may not be real. Step wrong, and the crust breaks, and your boot sinks into damp, salty mud that smells faintly metallic, like old coins and hot stone. In some pans, the mud below can be surprisingly warm, because heat does not stop rising just because the surface looks calm. And this is where the Afar Triangle gets good at mixing its dangers. The tectonics make the basin, the arid climate empties it, the volcanism warms it, and the salts preserve the whole story like a snapshot, right there on the surface. There are lakes here that are not really lakes in the way your mind wants them to be. They are brine bowls, bitter, dense water, heavy with dissolved minerals, the kind of water that makes your tongue immediately regret its curiosity. Lake Afdera is one of the better-known ones. It sits in a depression, surrounded by lava fields and arid slopes. Its water is saline, and its edges can be crusted white, with salt crystals forming like tiny, sharp flowers. In the right light, the lake can look inviting, blue against black rock, like a piece of ocean accidentally dropped in the desert. But it is not an accident, and it is not a gift. It is a storage tank of chemistry, fed and concentrated over time. People come here for that chemistry because humans have a special talent for seeing harshness and thinking, yes, but can I use it? Salt extraction in Afar is old work. You cut the crust into slabs, you stack the slabs, you load them, you haul them across the desert, sometimes by camel, sometimes by truck, because modernity arrives even in places that seem determined to resist it. The salt is valuable, but the work is slow, hot, and physically honest in a way most jobs have forgotten how to be. You are standing on the product of thousands of dry days, and you are watching it become a commodity, because that is what we do. We turn landscapes into inventory. The salt itself is not just table salt either. There can be layers and mixes. Sodium chloride, yes, but also other evaporite minerals depending on what dissolved into the water in the first place. Different inflows bring different chemistry. Volcanic rocks contribute their own suite of elements. Hot springs add more. Over a long time, the basin becomes a collector of the region's invisible ingredients. And sometimes, the basin does not just sit there quietly concentrating minerals. Sometimes it breathes. Hot springs are one of the clearest signs that the heat below is not theoretical. They can appear as small pools ringed with pale mineral deposits, with water that looks milky or faintly green, depending on what is dissolved inside. You approach and hear a soft simmer, not quite boiling, not quite still, like the ground is making tea you did not ask for. The smell can change as you get closer. Sulfur is common, that familiar sharp scent of a match just struck. It is hydrogen sulfide gas escaping, a reminder that the deep earth has its own atmosphere, and it leaks occasionally into yours. Steam vents, fumaroles, can hiss out of cracks in the rock. In the cool of night, the steam is more visible, a ghostly plume illuminated by moonlight. In the day, it vanishes into the heat haze, and only the sound remains, a steady exhale from the crust. You think of volcanoes as the dramatic part, lava, fire, glowing horizons. But geothermal heat is the quieter part, and in some ways, more intimate. It is warmth you can stand over. It is the planet's internal engine, idling just beneath your feet. Sometimes the minerals precipitate right at the surface, building little terraces and rims. Travertine, silica sinter, crusts that grow millimeter by millimeter as hot water cools and drops its dissolved load. They can be delicate, like chalky lace on stone. They can also be fragile, cracking under a careless step because they were never built for you. And because this is Afar, even the water has a complicated relationship with being water. It is often too salty to drink, too hot to touch, too mineral-rich to behave normally. It can be buoyant in a way that feels strange, pushing you upward if you try to float, as if the lake is trying to reject you gently. You start to notice how many colors a desert can contain. When water and heat collaborate, white salt, black basalt, rust-red sediments, pale tan dust, and sometimes a surprising green where algae or microbial mats find a niche in hot, mineral water. Life here is not absent. It is selective. Microbes thrive in places that would make larger animals miserable. They form thin films on warm pool edges. They stain rocks. They create subtle textures. They are the quiet workforce of chemistry, turning dissolved elements into biological patterns. It is calming, in an odd way, to realize the smallest life forms are completely unbothered by the conditions that intimidate you, and the basin keeps collecting. Each time a rare flood arrives, it spreads out, shallow and wide. Each time it retreats, it leaves behind a new crust. The landscape becomes layered, not in thick rock strata you need a cliff to read, but in surface skins, each one a season, a year, a decade. If you want to see deep time, sometimes you look for canyons and mountains. In Afar, you can also look at a flat, blinding salt pan and understand that it is a calendar made of leftovers. And once you have salt under your feet, you begin to imagine the other presence that salt implies. Because salt is not only a mineral, it is a hint. It suggests a history of water arriving in bulk, not just occasional rain, but something larger, something that could cover this whole depression. A sea, for example. The idea feels strange at first, because the air is so dry your lips crack, and the horizon looks like endless land. But you are already below sea level in places. You are already in a sagging bowl. You are already in the early architecture of a basin that wants to become ocean. The Afar Triangle sits near existing seawater, the Red Sea to the north and east, the Gulf of Aden to the east. These are not distant fantasies. They are nearby, separated from afar by ridges and high ground that are, geologically speaking, temporary. The same stretching that makes fissures and volcanoes also creates pathways. It lowers terrain. It changes gradients. It makes new low points that water would love to occupy if it ever gets the chance. A continent breaks slowly, and then suddenly it does not look like one anymore. You can picture the process like a zipper that starts with tiny teeth separating. At first, it is just cracks and shallow basins. Then, the basins widen, and some fill with lakes. The lakes become saltier as they evaporate. The crust continues thinning. Magma keeps intruding and building new rock. Eventually, if the rifting persists, the land can drop enough that seawater breaches the divide. That moment, when seawater arrives, is not a gentle little shoreline scene. It is an invasion. Salt water floods into low terrain, filling long troughs. It cuts off old roots. It turns familiar ground into coast. It changes the local climate too, adding humidity and storms to a place that has been living on dust and heat. In human time, it sounds dramatic. In Earth time, it is just the next step. The Afar Triangle is often described as a place where an ocean is being born. It is not poetry. It is a reasonable projection based on what rifts do when they succeed. If the rift keeps widening, the stretched continental crust can transition into oceanic crust. That new crust is mostly basalt formed by repeated eruptions and intrusions along a spreading center. It is like the planet's conveyor belt. New rock is made, pushed aside, made again, pushed aside again, over and over until a basin becomes a sea, and then a sea becomes an ocean. This is how the Atlantic Ocean opened long ago, when what is now Africa and what is now South America began to separate. Back then, the first stages would have looked a lot like this: rift valleys, volcanic fields, subsiding basins, lakes turning salty, and then, eventually, seawater pouring in to claim the low ground. You are looking at a familiar story, but in an early chapter. And early oceans do not look like the ones you know. They are narrow, they are raw, their coastlines are sharp, their cliffs are fresh, black rock that has not had time to soften. Their beaches are not wide and sugary yet. They can be jagged, gravelly, unstable, made of freshly broken stone. In some places, along young rifts, you can see what happens when water meets new basalt. Pillow lavas form underwater, bulging shapes created as lava erupts into water and cools rapidly, wrapping itself in a glassy skin. The forms look like a pile of dark cushions, which is almost cute until you remember the process involves molten rock meeting seawater with enthusiasm. If the Afar Triangle becomes a new marine basin, those kinds of features will become part of its future seafloor. The land you are lying on now could one day be underwater, quiet in a different way, with fish and currents moving above it, and sediments slowly settling onto it like dust on an old book. But that future does not arrive quickly. The rift moves at the speed of fingernails, millimeters a year, a pace so slow you could live a whole life and call it stable. And then, in some brief episode, a dike intrudes, an earthquake sequence rattles the region, the ground opens by a meter, and suddenly your lifetime has a visible change in it. That is the rhythm again. Long quiet, then a stitch of sudden movement. It is also why predicting the exact timeline is a fool's errand. Geology does not respect calendars. It respects stress and temperature and rock strength. It moves when it is ready, not when you are. Still, you can stand in Afar and see the ingredients laid out: thin crust, active rifting, volcanism, subsiding basins, nearby seas. It is like watching a recipe come together, one slow stir at a time. And as you imagine that future coastline, you start noticing shorelines that already exist, not of ocean water, but of lakes that have come and gone, old beach ridges, lines of gravel, changes in sediment color that mark ancient water levels. The land holds these memories quietly, like wrinkles that only show in certain light. You think of coastlines as lines on maps, neat boundaries, but coastlines are arguments. They are places where water insists and land resists, and neither side fully wins. A future Afar coastline would not be stable. It would erode. It would retreat in cliffs, especially where waves attack young volcanic rock fractured by cooling and faulting. It would build small deltas where seasonal floods bring sediment. It would grow salt marshes in sheltered inlets. It would shift with storms, and even before any sea arrives, you can see the same logic in miniature around the edges of brine lakes and seasonal pools. A thin crust breaks underfoot like ice. A small wave, pushed by a faint breeze, taps at a rim of salt and rearranges crystals. It is coastline behavior, just scaled down. It is comforting, in a way, to realize that the world does not need grandeur to be active. A shallow puddle in a salt pan is already doing the work of shaping edges and sorting grains. The patience of it is almost insulting, but it is also reassuring, because if landscapes can change without asking permission, then it means your own life can change the same way, quietly, slowly, in small shifts that add up. No announcement required. And speaking of water arriving and leaving, once you start paying attention to how water shapes land, you realize the most persistent sculptor on Earth is not fire. It is not ice. It is moving water, doing demolition with the calm professionalism of a worker who never takes a day off. Even in deserts, water leaves its signature because it only needs to visit occasionally to make a point. You follow a dry channel, a wadi, etched into the ground like a vein. In the day, it is dust and stones. At night, it is a darker line across the terrain. It looks harmless. It looks finished. But it is a route, a path, waiting for the rare moment when rain falls upstream and gravity remembers what to do. Rivers are not always rivers. Sometimes they are just the possibility of a river. And the possibility is enough to carve. You can picture a drop of water landing on a slope. It does not know where it is going. It simply goes down. It slips between grains of sand. It gathers with other drops. It becomes a thin sheet, then a trickle, then a thread of flow. Then, if the rain is generous or sudden, a surge that carries pebbles like they are toys. The first time you see a flash flood in a dry land, it feels like a prank. A channel that was silent becomes loud, brown water churning, dragging branches, stones, and the occasional unlucky object humans left in its path. Because humans have a special faith in things staying the way they looked yesterday. But the real work happens even when the flow is not dramatic. It happens in repetition. Water is heavy, and moving water has energy. It uses that energy to pick up sediment and carry it. It scrapes rock with sand like sandpaper. It wedges into cracks, loosening pieces. It dissolves minerals, especially in certain rock types. It rounds stones. It sorts grains by size, like a patient librarian organizing a chaotic collection. A river does not need to be fast to be effective. It needs time. And rivers, unlike you, are not bothered by waiting. If you stand beside a river, any river, you are standing beside a moving conveyor belt of tiny yaternis, grains of sand that were once part of a mountain, silt scraped from a hillside, clay formed from the chemical breakdown of rock, all of it traveling downhill because the planet is always trying to flatten itself. That is the core tension of landscapes. Tectonics builds relief, rivers erase it, mountains rise, rivers cut them down over and over. It is a slow argument between uplift and erosion, and rivers are the part of the argument that never sleeps. In Afar, you might not see a big permanent river nearby, but the logic is the same. Water flows from higher ground toward lower basins. It carves channels where it repeats its path, and when it finally settles in a depression, it leaves sediment behind. Layers of fine material that later can harden into rock, or just sit there, waiting for the next flood to rearrange them. Now, let your attention drift away from Afar for a moment, because rivers are the kind of story that refuses to stay in one place. They connect landscapes. They take material from one world and deliver it to another. Imagine you are no longer a person on warm stone. Imagine you are a grain of sand, chipped from a volcanic rock, released by heat and cracking, and finally freed by water. At first, you are stuck, wedged in a rough surface. Then a rare rainstorm arrives, and you are lifted, rolled, knocked against other grains with the gentle violence of transport. You bounce along the bed of a small stream. You are carried into a larger channel. You settle briefly in a quiet pool, then another flood picks you up again. Your journey is not heroic. It is repetitive. It is being dropped and picked up over and over, with long pauses in between. That is how rivers do big work. They do it with boredom. As you travel, you notice how a river makes a valley, not in one dramatic cut, but by concentrating flow. Water finds the lowest path. The lowest path becomes lower. The channel incisors, cutting down. The sides slump and collapse. The valley widens. A small gully becomes a ravine. A ravine becomes a canyon. And if the land is rising at the same time, because tectonics is still pushing upward somewhere, the river responds by cutting deeper. It maintains its gradient as best it can, like a tired worker trying to keep up with a boss who keeps raising expectations. This is why some of the most dramatic canyons exist, where uplift and rivers meet. The land rises, the river cuts down, and you get a deep incision that feels almost impossible, a wound that takes millions of years to open. But you do not need a famous canyon to understand the principle. Any little stream bank shows it. You can see undercutting where flow eats the base of a bank. You can see collapse where soil gives in. You can see roots exposed like nerves. You can see fresh sediment bars forming on the inside of bends where water slows and drops its load. A river is not a straight line. It is a moving shape. It meanders because water, like most things, prefers the path of least resistance, and because small imperfections in flow amplify over time. A tiny bend becomes a bigger bend. Erosion on the outside of the curve, deposition on the inside. The bend migrates. The river shifts across its floodplain like a slow, indecisive animal. People love rivers for obvious reasons. Water to drink, soil to farm, fish to catch, a corridor to travel, a place to settle. And then, with impressive consistency, people act shocked when a river does what rivers do. They build houses on floodplains because floodplains are flat and fertile and convenient. They forget that the fertility comes from floods. They straighten channels to make navigation easier, then wonder why floods get worse downstream. They build levees, and the river responds by rising higher, trapped between walls, like a patient thing becoming more focused. Congratulations! You have taken a system that disperses energy across a wide area, and you have forced it into a narrow corridor. Nature appreciates your confidence. Over long time, rivers also build. They are demolition crews, yes, but they also deliver material. Where they slow down, they deposit sandbars, floodplain layers, deltas at the sea. A river's mouth is not an ending, it is a spreading. When a river meets still water, like a lake or ocean, it loses energy. It can no longer carry the same sediment load, so it drops it, grain by grain, layer by layer, building new land outward. The river splits into distributaries, multiple channels, because the sediment clogs one path and forces the water to find another. This is how deltas form. Soft triangles of sediment at the edge of larger water bodies, constantly reshaped by flow and storms and tides. Deltas are temporary land, built by rivers and stolen back by the sea. A negotiation that never quite settles. And even if you are far inland, you are connected to that edge. Because the sand you are imagining yourself as, it is headed there, eventually. Maybe not this year, maybe not in your lifetime, but the direction is downhill. And the planet has time. So when you think about Afar again, you see it differently. The rift is building a basin. Rivers and ephemeral flows are filling it with sediment. Salt pans are concentrating minerals. Volcanoes are adding fresh basalt. Everything is moving material from one place to another, sorting and rearranging the surface like a slow, endless cleanup. And the whole time, the low ground keeps lowering, the crust keeps thinning, and the idea of seawater keeps waiting nearby like a patient visitor. Rivers are the middlemen in this story. They take the highlands apart and deliver them to the lows. They are the reason mountains do not get to keep their height forever. They are the reason continents, over enough time, could become smooth if tectonics ever took a break. But tectonics never really takes a break. It just changes tempo. And when a river finally meets the ocean, when it brings its load of sand and silt to the edge of a continent, the story does not end. It changes shape. It becomes shoreline. Because coastlines are where all this transported material has to face a new kind of motion. Waves. Waves are just wind energy traveling through water, but they behave like a relentless committee, arriving in endless meetings, making the same point again and again. They lift and drop. They shove and pull. They sort sediment by size. They find the weak point in a cliff and return to it like someone worrying a loose thread until it becomes a tear. You can stand on a coast and feel how busy it is, even when it looks calm. The water is always moving. The tide is always changing. The wind is always rewriting the surface texture. The shoreline is not a line. It is a zone, an argument, a place where the planet refuses to draw boundaries neatly. And the sea is patient in a way that should make you nervous. A cliff looks permanent. It looks like the final word of rock, but waves do not need to be strong all the time. They just need to keep arriving. They exploit fractures. They compress air into cracks, and the pressure helps pry rock apart. They remove fallen debris so the base stays exposed. They undercut, and gravity does the finishing work. From the top of a sea cliff, the view can be beautiful. Far water, pale horizon, gulls tracing circles, but the cliff edge is often retreating centimeter by centimeter, collapse by collapse. Sometimes it fails suddenly, a slab breaking away, the sound like a door slammed by the planet itself. If you have ever walked near a cliff edge and felt a little uneasy, that is not irrational. That is your body correctly interpreting the fact that coastlines are not stable architecture. They are temporary. Then there are beaches which look like rest. They look like peace. But a beach is just sediment in transit. Sand moves along the shore in a process called longshore drift. Waves approach at an angle, pushing sand diagonally up the beach, then gravity pulls it straight back down. The net movement is sideways. Grain by grain, the beach migrates. This is how barrier islands form in some places. Long, narrow strips of sand parallel to the mainland, built by wave action and currents, reshaped by storms. They are not permanent islands. They are sandbanks that happen to be above water most days. They move, they break, they reform, and humans, with that familiar optimism, build expensive houses on them and call it coastal living. Congratulations. You have built a mortgage on a pile of sand that only exists because the sea has not had a strong opinion this season. Deltas, too, are vulnerable. They are made of loose sediment, often barely above sea level. They sink naturally as their sediments compact. They can also sink faster when humans extract groundwater or oil and gas, removing support from below. Meanwhile, the sea keeps rising and storms keep arriving, and the delta has to fight to stay land at all. So the coast is always being rewritten. Erosion removes land in some places, deposition adds it in others. Storms can rearrange a beach overnight. A single hurricane can cut a new inlet through a barrier island, turning one island into two, just to keep things interesting. And beneath it all, sea level changes over time. Not just from modern warming, but from the slow breathing of ice ages, the storage and release of water in glaciers, the expansion and contraction of seawater as the planet warms and cools. Coastlines migrate in and out over thousands of years, leaving behind old shorelines inland, like ghost beaches. If you want to feel small, stand on a coast and imagine where the waterline was 10,000 years ago. It was not here. It was far out on what is now seafloor. People once walked there, hunted there, watched sunsets there. On land that is now drowned, the coast does not care about your sense of ownership. It does not care about property lines. It cares about energy and sediment and time. And now you can see the connection again. Afar is a place where a coastline may someday appear. If it does, that coastline will not be stable. It will be raw and active and constantly adjusting, because the land beneath it will still be moving, still stretching, still subsiding in places. A young ocean margin is not a quiet neighbor. It is a construction site with waves. But water does not only move as liquid. There is another version of moving water that changes continents with a different kind of patience. Frozen water. Ice is water that has decided to become heavy. A glacier does not look like a river at first. It looks like stillness, like a bright, silent mass parked in a valley. But glaciers flow. They deform under their own weight, creeping down slope, dragging rock, grinding valleys into new shapes. If rivers are the world's slow demolition crew, glaciers are the demolition crew that shows up with a bulldozer, turns off the engine, and then pushes anyway. The ice moves because pressure makes it behave plastically. The crystals within the ice rearrange. The base may melt and refreeze. Meltwater can lubricate the bed, allowing the glacier to slide. The motion is slow enough to feel unreal until you put stakes in the ice and come back later and realize the whole thing is shifted. And as it moves, it carries debris. Rocks fall onto the glacier from valley walls. The glacier picks them up. It freezes them into its base. Then it drags them along like sandpaper, scraping the bedrock beneath. This is why glaciated landscapes look different. Valleys carved by rivers tend to be V-shaped, cut sharply downward. Valleys carved by glaciers tend to be U-shaped, wide-bottomed and steep-sided, because the ice fills the valley and grinds not just the center, but the sides too. Even after the glacier retreats, the valley remembers. You can see glacial polish on rock surfaces, smoothed and shiny, with striations, scratches that mark the direction the ice once moved. You can find erratics, boulders dropped far from their original source, because the glacier carried them like baggage and then abandoned them when it melted. And when glaciers melt, they do not just leave scenery, they change the very posture of the land. A thick ice sheet is a weight, a crushing one. It pushes the crust down, depressing it into the mantle below. When the ice melts away, the land slowly rises back up, a process called isostatic rebound. It sounds like a trampoline trick. It is actually the Earth's crust recovering from being sat on by a continent of ice. The rebound can continue for thousands of years after the ice is gone. In some places, the land is still rising today, millimeter by millimeter, quietly changing relative sea level. A coastline can emerge not because the sea is falling, but because the land is lifting. So water, in ice form, can rewrite coasts too. Imagine a fjord, a long, narrow sea inlet with steep walls. It looks like a dramatic coastline feature, carved by waves. But many fjords are glacial valleys drowned by rising sea after the ice melted. The sea simply moved in and occupied the shape the glacier made. The coastline inherits the work of ice, and ice, like rivers, is obsessed with time. It advances and retreats with climate cycles. It expands during cold periods. It shrinks during warm ones. It shapes, leaves, and then disappears, sometimes so completely you would not believe it existed if the valleys were not so unmistakably carved. This is the sleepy trick of geology. The evidence remains, even when the actor is gone. Now, you might wonder why we are talking about ice while you are still mentally warm from afar, because this planet does not allow you to stay in one climate forever. The same Earth that tears open hot rifts also grows ice sheets. The same water that evaporates from salt pans also falls as snow and becomes a moving mass. The loop is wide. Heat and cold are both tools. And after you have followed water in all its forms, you start to notice that deserts, too, are shaped by motion you cannot always see, not just water's rare visits, but wind's constant touch. But wind is later. Wind is what you think of when the cold silence of glaciers feels too heavy, and you want to return to a world where the air itself does the carving. For now, you are still standing in the wake of water, imagining it as a river, a coast, a glacier, and noticing the same lesson everywhere. The surface is not finished. It is always being transported, resorted, and rearranged, one grain at a time, toward whatever low place waits at the end of the slope. So you follow that grain a little longer, and you realize the low place does not have to be wet. Sometimes the low place is simply where the wind decides to park its patience. You step out into a desert at night, and it feels like the world has been muted. The heat that bullied you all day has finally eased off. The sky is so crowded with stars that it looks textured, like salt crust. And the ground is a mix of hard and soft, of stone and loose grit. You think deserts are empty because nothing moves. Wrong. Deserts are busy. They just do their work quietly, and mostly at ankle height. Wind is not a sculptor with a chisel. Wind is a tired janitor with a broom sweeping the same hallway forever. It cannot lift the big rocks. Not usually. It picks up the small stuff, the sand, the silt, the dust, and by removing the small stuff, it exposes the big stuff and changes everything. That is the first desert trick. Not building, but revealing. You walk across a flat that looks smooth in the dark. In daylight, you would see it is covered in tiny pebbles. A pavement. A desert pavement sounds like an urban planning project, but it is not. It is what happens when wind removes finer grains and leaves the heavier stones behind. The surface becomes armored, as if the land learned to defend itself. The pebbles protect the soil beneath from being lifted away. It is stability created by theft. In some places, those pebbles have a dark sheen, desert varnish, a thin coating of clay minerals and trace metals slowly accumulated. Manganese and iron laid down over a long time with help from dust and moisture and microbes. It is one of those features that looks like a finish, as if someone polished the stones. But it is just another layer of patient chemistry happening so slowly it feels like a rumor. If you sit with it, you start seeing deserts as archives, not empty, just stripped down to essentials: rock, wind, light, and time. And then there are dunes. The dunes are where the desert stops pretending it is still. A dune looks like a frozen wave, a smooth slope, a sharp ridge, a soft curve. You think it is a stable hill. Wrong again. A dune is a moving crowd of grains, migrating one small decision at a time. Here is how it happens, in the simplest way. Wind pushes grains up the gentle side, the windward slope. Each grain hops, a motion called saltation, like it is skipping. At the ridge, the wind loses its grip for a moment. The grains tumble down the steep side, the slip face, and the whole dune inches forward. It is not fast. It is persistent. It is a landform that behaves like a slow animal, always facing into the wind, always traveling. You can hear it sometimes, not always, but in the right conditions, dunes can hum, a deep, low note produced when dry sand grains slide together in a synchronized way. It is called singing sand or booming dunes. It sounds like the desert clearing its throat. It is unsettling, but in a gentle way, like the landscape has a voice, and it chooses to use it rarely. The desert wind is selective about what it can carry. Dust can stay suspended for a long time. It can cross oceans. Sand is heavier, so it stays lower, moving in hops and skitters. Gravel stays put, mostly, so the desert sorts itself, grain size by grain size. And because the wind is always sorting, you get patterns, ripples like miniature dunes, lines of pebbles, bands of different textures laid out as if the land is organizing itself into neat rows. You might think that these patterns are decoration. They are not. They are physics leaving handwriting. Now think about abrasion. Wind is not just moving grains, it is throwing them. A sand grain hitting rock is small, but it is constant. Over thousands of years, that becomes sculpting. You see rocks shaped like pedestals, wider at the top, narrower at the bottom, mushroom rocks. Because sand moves close to the ground and it blasts the lower part more, the base gets carved faster until the rock looks like it is balancing. It is not balancing. It is being undermined. You find stones with flat faces, sharp edges, as if they were cut, ventifacts, rocks shaped by wind-driven sand, polished and faceted. They can look deliberate, like tools, but it is only the wind doing the same thing for a very long time. Congratulations, you have discovered that nature can sandblast without owning a compressor. Deserts also collect dust in places where the wind slows down, behind shrubs, in shallow hollows against the leeward sides of hills. Dust becomes a kind of currency, moving around until it finds a place to settle. And that dust matters, because dust is not just dirt, it carries nutrients, iron, phosphorus, and other elements that ecosystems use. Dust from deserts can feed distant forests and oceans. The Sahara, for example, exports dust across the Atlantic. Some of that dust ends up over the Amazon basin. It helps replace nutrients washed out by heavy rainforest rain. So the desert is not isolated. It is connected. Even the emptiest looking places can be suppliers. At night, you can feel the desert doing one of its most dramatic tricks: temperature swings. During the day, sun pours energy into the ground. At night, with clear skies and dry air, that heat escapes fast. The ground cools, and the air just above it cools too. You can feel a shallow layer of cold forming close to the surface, like a thin liquid. This is why deserts can feel surprisingly cold at night, not because they are near ice, but because they are good at losing heat. And those temperature changes break rock. Expansion in the day, contraction at night, again and again. It is called thermal stress, and over time, it helps fracture stone. There is also salt, not just in Afar. In many deserts, salts in pores of rock can crystallize. They grow and push outward, prying grains apart. Salt weathering can make cliffs crumble into sand and gravel. The desert takes rock apart in quiet ways. It does not always need water to do it, though. Water helps when it shows up. And when water does show up, deserts become briefly loud. You find channels that look like scars, dry washes, arroyos, wadis. Most nights, they are empty. But when rain falls, especially far upstream, they can fill fast. The flow is short-lived, but it can move boulders. It can rip out shrubs. It can carve the channel deeper in one event. Desert rivers are not about consistency. They are about intensity. The land here learns to live with long waiting, then sudden force. Plants grow low, thorny, conservative. Animals become nocturnal, or burrowing, or both. Everything becomes efficient with water, because water is never guaranteed. You start to understand that deserts are not dead. They are disciplined. And now, the planet offers you a different kind of desert. A cold one. Because if you strip away rain and keep the air dry, you can have a desert even under snow. Antarctica is the largest desert on Earth by precipitation, not by heat, by dryness. It is strange to hold that idea, a desert made of ice. But it fits the definition. Desert means little precipitation, not necessarily sand. In the cold desert, wind still rules. It scours snow into hard ridges called sastrugi. It blows so persistently that the surface becomes sharp, sculpted into frozen waves. And the dryness means ice does not always melt. Sometimes it sublimates, going from solid to vapor. The ice vanishes without becoming water, a clean disappearance. So whether the desert is hot or cold, the theme is the same. Take away steady water, and the landscape becomes a place where air, temperature, and time get louder. Now let the scene shift again, not to a new postcard, but to a familiar pattern. Because deserts are where you can watch one of Earth's favorite cycles in slow motion. Rock breaks down into particles. Particles move. Particles gather. Particles harden into rock again. In a desert, this cycle is exposed. You can see the pieces in transit. And somewhere in that transit, your grain of sand has choices. Not choices like a person, choices like physics. If the wind is strong enough, you travel. If it is not, you settle. If a rare flood arrives, you get scooped up and carried in water instead of air. If you end up in a basin, you might be buried by more sediment. If you are buried long enough, pressure can compress you. Lithification. It is a serious word for a simple idea. Loose grains becoming rock. Sediment turns into sedimentary rock through compaction and cementation. The grains get squeezed. Minerals precipitate from water in the pores, acting like glue. Congratulations! You have become part of a future cliff. Sandstone is often born this way. It can hold cross-bedding, angled layers formed by migrating dunes. So a desert can become rock, and that rock can later be uplifted, exposed, and eroded again. A stone desert made from an ancient sand desert. The planet loves recycling. You can see ancient dunes preserved in stone in places like the southwestern United States, in the Navajo sandstone. Great sweeping layers, frozen in rock, showing where dunes once leaned into ancient winds. It is one of the most soothing facts about geology. If you let it be, even chaos leaves patterns, and the patterns can be preserved. Now you begin to feel the loop tightening. Rifts create basins. Basins collect sediment. Wind and water move grains. Sediment becomes rock. Tectonics lifts rock. Erosion breaks it down again. Nothing is wasted. Everything is delayed. And when you zoom out far enough, you start to see that the places you visited tonight were never separate stories. They were chapters of one system told with different textures. In Afar, the crust stretches. That stretching creates low areas. Low areas trap water when it exists. Evaporation leaves salt. Magma rises through the weakness, adding new rock. Rivers when they appear, carry material in. Wind takes finer grains out. It is all one slow rearrangement, the planet shifting its weight. You can imagine it like a long conveyor belt, but not a neat factory belt. More like a messy house move that never ends. Boxes get opened, repacked, moved to another room, forgotten, found later. Mountains are not permanent furniture. They are stacks of material waiting to be carried away. Oceans are not permanent either, at least not on the biggest clock. They open and close over hundreds of millions of years. Continents assemble and split like shy animals that cannot decide whether to gather or scatter. There is a name for this long rhythm: the supercontinent cycle. At times in Earth's past, most land was gathered into one huge mass. Pangaea is the famous one, but not the only one. Before it, there were others, like Rodinia. Each one assembled through plate collisions, then later broke apart through rifting. The Afar Triangle is a tiny part of that ancient pattern. Not the whole event, just a seam beginning to unzip. And the strange comfort is that this is normal. Not normal for your daily life. Normal for Earth. You are living on a planet that does not settle. It only pauses. Now, if you follow the water part of the loop again, you see how the cycle links to climate. Ice ages, warmer periods, sea levels rising and falling, rivers cutting deeper when sea level drops, then filling valleys when sea level rises. During colder times, more water is locked in ice. Sea levels drop, rivers gain potential energy because their base level is lower. They incise deeper valleys. They carve. They deliver sediment to the continental shelf, which becomes exposed land. During warmer times, ice melts, sea levels rise. Rivers lose some cutting power near their mouths. They deposit sediment, building floodplains and deltas. So the same river can alternate between cutting and filling, depending on the planet's temperature mood. The coastline moves in response, sometimes far inland, sometimes far seaward. The shore is a moving target over thousands of years. Now add isostatic rebound, the land lifting after ice melts. That changes relative sea level too. In some places, the sea appears to fall because the land is rising. In other places, the sea appears to rise because the land is sinking. It becomes a layered story, not one cause, many causes, stacked, and humans entering this story late often assume the current arrangement is the permanent one. It is an understandable mistake, but it is still a mistake. You build a city near a river mouth because trade and water and flat land. Then the delta subsides and storms arrive and the sea creeps in. You build seawalls and pump stations and argue with the ocean. The ocean does not argue back. It just keeps showing up. You build on barrier islands because the view is good. Then a storm reorganizes the sand overnight. Your neighborhood becomes an inlet. Your street becomes a channel. The maps are embarrassed. The waves are not. You build in arid lands because technology makes it possible. Pumps and canals and reservoirs. Then drought stretches longer than expected. The water budget becomes a fantasy. The landscape does not care that you expected normal. It never promised normal. But this is not meant to be grim. It is meant to be clarifying. Because when you accept that Earth is indifferent, you stop taking its behavior personally. You stop expecting stability as a right. You start seeing stability as a temporary gift, and that can be calming in a bleak, cozy way. Now, drift back toward Afar again, not as a place on a map, but as a sensation. Warm rock, dry air, the faint smell of minerals, the kind of quiet that is not emptiness, but distance. Afar sits where the crust is thin and heat is close. That means the cycle can move faster there, geologically speaking. Rifting lowers the land. Lower land invites water. If the barriers break, water changes chemistry. Chemistry changes rock. Heat changes everything. If seawater eventually enters, you will get a new coastline, a new humidity source, new erosion patterns. Storms might become more common because warm water fuels weather. The region could shift from purely desert logic to a mix of coastal and desert logic. In some rifts, this early ocean stage becomes a long, narrow sea, like the Red Sea itself. A young ocean basin, still opening, still bordered by tectonically active margins. The Red Sea is basically a more advanced version of what Afar hints at. It began with rifting, volcanism, and thinning crust. Now it contains oceanic crust, forming along a spreading center. The same process can happen again, southward. If the rift keeps going, the Gulf of Aden is similar, a spreading system connecting into this triple junction region. So Afar is not only dangerous because of earthquakes and heat, it is dangerous because it is a hinge in a bigger mechanism. It is a place where the planet is changing categories. Land toward sea, continent toward ocean basin. Categories feel stable to humans. We like labels. Desert, mountain, coast. But Afar is a place where labels are premature. And that is why it is such a good bedtime landscape, in a strange way, because it tells you, quietly, that nothing is required to stay as it is. Now let your mind linger on a simple image, not a dramatic eruption, not a headline earthquake, a small crack in the ground, a fissure that appeared after a rifting episode. In the day, it is harsh. In the night, it is just a dark line. You stand beside it, and you cannot see the bottom. The edges are sharp basalt, newly broken. You think the crack is an empty space, but it is also a boundary, a place where gases can seep out, a place where heat moves upward, a place where, someday, water might move in. It is a future in miniature. And now, the loop widens again, because Earth does not let you stay focused on one crack for too long. It wants you to think in systems. So, you think about the carbon cycle without making it complicated. Volcanoes release carbon dioxide, CO2, from deep sources. Weathering of rocks can remove carbon dioxide from the air over long time, locking it into carbonate minerals. Rivers carry dissolved ions to the sea. Marine organisms can use those ions to build shells, which become limestone when buried. It is slow, but it is real. The solid Earth and the atmosphere trade materials over millions of years. When rifting increases volcanism, it can increase carbon release. When mountains rise, weathering increases, drawing down carbon. So, tectonics and climate are connected, like distant roommates who affect each other without speaking. The planet regulates itself, not with intention, but with feedbacks. Push here, something responds there. This does not mean everything stays comfortable. It means the system has ways of shifting, and your job tonight is not to solve it. Your job is only to notice how patient it all is. Now, if you think about glaciers again, you can connect them back to deserts. When climate shifts colder, glaciers grow and sea level drops. Some regions become drier because cold air holds less moisture. Winds can strengthen around ice sheets, blowing dust. Glacial periods often come with dustier atmospheres. The world gets more abrasive. You can even find lowest deposits, wind-blown silt, piled thick in some regions. Soft, fine sediment carried by wind from glacial outwash plains. It forms fertile soils later, which humans love because humans love anything that makes farming easier. And then humans build civilizations on those soils and later act surprised when rivers cut into them or when drought arrives. The story keeps repeating. Different actors, same plot. Now, let us walk through one more desert night scene, slowly, because the desert is where time feels most honest. You are on a plain of sand and gravel. The wind is light, but not absent. It moves against your skin like a soft brush. In the distance, you see a low ridge, not high enough to be a mountain, just a rise. That rise matters because it interrupts wind. On the windward side, the air speeds up and scours. On the leeward side, the air slows down and drops sand. So dunes may form in the lee, not randomly. In response to obstacles, desert landscapes often look chaotic, but they have rules. Wind direction, sediment supply, vegetation, if any, anchoring grains, moisture, even a little, changing how sand sticks. If sand is damp, it clumps, and dunes behave differently. If sand is very dry, it flows. This is why dunes can shift seasonally in some places. Dry season, more movement. Wet season, more stability. And it is why vehicles can get trapped. Sand that looks firm can be powder. Sand that looks loose can hide a crust beneath. The desert enjoys misleading you, not maliciously, just as a side effect of being a place where surfaces change quickly. Now, some deserts have another feature, one that feels almost like the land is playing a trick: playas, dry lake beds. A playa is a flat basin where water collects and evaporates. It can be clay-rich, smooth, and cracked into polygon patterns when dry. Those cracks happen because the mud shrinks as it dries, pulling apart into geometric shapes. It is a slow, quiet geometry. In the right light, those polygons look like scales, like the land is reptilian, cozy geological horror in its natural form. And sometimes, after rain, the playa becomes a shallow lake again, a thin sheet of water, reflecting sky. Then it vanishes, and the cracks return. The desert is good at temporary miracles. Now connect that to Afar's salt flats. Different chemistry, similar idea. A basin that collects, then loses water to evaporation. A surface that looks like something else from a distance. A place where you learn not to trust the horizon. In Afar, the evaporites can be thick. In other deserts, it might be clay crust, but the principle is the same. Low place, rare water, strong sun. Leftovers. And those leftovers can preserve footprints, animal tracks, human tracks, Even ancient tracks, if conditions are right and sediments later harden, deserts can preserve because they are dry. They can also erase because they are windy. Preservation and destruction, side by side, depending on timing. The planet is not consistent. It is opportunistic. If you stay in this thought long enough, you start seeing why deserts are often where we find deep history, not only fossils in rock, but artifacts on the surface. Dryness slows decay. Sparse vegetation leaves things exposed. Erosion can reveal buried layers. Of course, erosion also destroys, but it destroys while uncovering, like a thief who accidentally opens a curtain. So deserts become museums with no roof, curated by wind. Now, step away from the sand again and let the scale stretch. Because the loop is not only on land, sediment carried by rivers reaches the sea. Some of it is trapped near shore, building beaches and deltas. Some of it travels farther, down submarine canyons, into deep ocean basins. Yes, the ocean has canyons too, cut into continental shelves and slopes. Some were carved when sea level was lower and rivers extended farther. Some are maintained by turbidity currents, underwater avalanches of sediment-rich water that flow downslope. Imagine that. A river not of fresh water, but of muddy density, sliding along the seafloor, carrying sand into darkness. These flows can deposit layers on the abyssal plain. Over time, those layers can become rock, sandstone beds, shale beds, stacked like pages. Then tectonics can later lift them, fold them, expose them on land, and you can stand on a mountain made of old seafloor sediments, which is always a good reminder that the categories are temporary. The Himalayas contain marine sediments high above sea level. Shells, limestones, evidence that these rocks were once on the bottom of an ocean. Congratulations, you are hiking on the ghost of a sea. So, the loop includes the deep ocean too. Not just coasts and rivers and deserts, but abyssal plains and trenches. And where plates meet, the loop gets another twist. Subduction. In some places, oceanic crust is pushed back into the mantle. It carries sediments with it. It carries water bound in minerals. It carries carbonates. As it descends, it heats up. Water is released, helping melt the mantle above. Magma rises. Volcanoes form. So the sediment that was once a mountain, then a river lode, then a delta, then seafloor, can be returned to the mantle and later re-emerge as volcanic rock. It is not a circle you can watch in a lifetime. It is a circle you can only understand by letting your mind move slowly. And that is the kind of movement the planet respects. Now, return again to the idea of danger, because the title promised danger, and Afar wears it like a quiet badge. Afar is dangerous because it stacks risks, heat stress, dehydration, remote terrain, political complexity at times, and the geology, earthquakes, fissures, volcanic gases. But the danger is not constant spectacle. It is the background condition of instability. A fissure can open and cut a road. An earthquake swarm can rattle sleep and then stop. A volcanic vent can release gases that collect in low areas. Carbon dioxide, for example, is heavier than air. It can pool in depressions. In rare cases, it can suffocate animals that wander into the wrong hollow. Most of the time, you never notice. That is the point. The hazard is quiet, and people live with it anyway, because humans are adaptable and because home is not chosen only by safety. It is chosen by history, by culture, by livelihood. In Afar, salt work continues, pastoralism continues, trade routes exist, life threads itself through harshness. The planet does not make it easy, but life rarely waits for easy. Now, the loop is still looping, and you are still inside it. Rift, volcano, salt, river, coast, ice, desert, each one a tool the planet uses to move material around. And you begin to sense that the calm part of this story is not that Earth is gentle, it is that Earth is consistent in its inconsistency. It breaks things, it builds things, it erases things, it repeats. If you can accept that rhythm, you can stop expecting permanence from surfaces, including the surface of your own plans. Now, the next part of the journey is not a new landscape. It is the same landscapes seen as one continuous machine. You can picture the Earth as a heat engine. Heat from the interior drives convection in the mantle. That motion moves plates. Plate motion builds mountains, opens rifts, creates volcanoes. Mountains influence climate, steering winds, creating rain shadows. Climate controls erosion, ice, rivers, deserts. Erosion moves material to the sea. Sediment gets buried, subducted, melted, recycled. The loop closes, then starts again. And the strangest part is how slow it feels from inside it. From your perspective, nothing changes. Until it does. A coastline retreats a little each year, but you only notice after a storm removes meters overnight. A glacier thins slowly, but the moment it calves, it sounds like thunder. A desert dune migrates quietly, but eventually it covers a road. A rift widens millimeter by millimeter, then suddenly cracks open in a week. Earth saves its drama for punctuation marks. Now imagine you are standing again in Afar, at the edge of a salt flat. The crust underfoot is pale and brittle. Beyond it, black lava fields stretch like cooled oil. You look up, and the stars feel close because the air is so dry and clear. There is a faint breeze, and it carries dust that tastes mineral. Somewhere under you, the plates are still pulling apart. Not enough to feel in your muscles, enough to exist. And you realize this place is not an exception. It is an example. Most of the planet is doing something similar, just in different forms at different speeds. The Andes rise because a plate is subducting. The Himalayas rise because two continents collided. Iceland sits on a mid-ocean ridge where new crust is made. California slides along a transform fault where plates grind sideways. Afar is simply where you can watch the beginning of an ocean on land, a rare transparency. And once you have seen that, it becomes easier to see the same honesty elsewhere, not as danger necessarily, but as process. Now let your mind settle into the deep time view, not as a conclusion, but as a wider lens. You are not watching events. You are watching tendencies. The planet tends to cool on the inside, but it is still hot enough to move. It tends to flatten itself, but tectonics keeps wrinkling it. It tends to sort materials by density and size, through wind and water. It tends to recycle crust, especially oceanic crust, through subduction. And life tends to occupy any crack it can. Even in Afar, microbes stain hot pools. In deserts, crusts form, biological soil crusts made of cyanobacteria and lichens, binding grains and reducing erosion. In cold deserts, life persists in sheltered microclimates. Life does not stop geology, but it can influence the surface. It can stabilize dunes with roots. It can change weathering rates. It can build reefs along coasts, which become limestone, which becomes mountain later. It is a small actor with long reach. Now, if you want a final grounding image for this stretch of the story, take the simplest one: a single grain moving. In one era, it is blasted by wind across a dune field. In another, it is carried by a flash flood into a basin. In another, it is buried under more layers. In another, it is cemented into stone. In another, it is uplifted and exposed and broken free again. The grain does not remember, but the landscape does in its shapes. And you are allowed to borrow that patience, not to end anything, just to keep moving through it, slowly, without needing the surface to be finished. Because somewhere out there, under a different patch of stars, water is freezing into a new layer of ice. And that ice is already beginning to move. That ice begins as a thin skin stitched across a quiet bay, or laid down grain by grain on a high plateau where the air is too dry to feel merciful. It starts light, almost delicate, and then it keeps arriving. Snow on snow, wind packing it tighter, layers pressing down on layers until the bottom ones stop being snow at all. They become ice that can bend. You think ice is brittle, a thing that shatters and snaps. Wrong. Under enough weight, ice behaves like a very slow liquid. It creeps, it deforms, it flows downhill with the same obedience as water, only with a patience that borders on insulting. You are standing on it now, not as a hiker, not as a tourist, but as a small pressure point on a moving field. Beneath you, the ice is not sliding smoothly like a sled. It is doing something more awkward. It is squeezing around rocks. It is cracking, then healing. It is grinding its own bed into powder. Glaciers move in two main moods. One is internal deformation, the ice crystals slowly rearranging under stress. The other is basal sliding, when meltwater at the base acts like lubrication, letting the whole mass slip over rock. The second one sounds faster. And sometimes it is, but it comes with a price. Meltwater finds weaknesses. It drills downward through crevasses. It forms molens, vertical shafts that swallow surface water and deliver it to the base. And once water is down there, it becomes a lever changing friction, changing speed, changing where the glacier grips and where it lets go. Congratulations, you have found a river that runs inside a river. And just like liquid rivers, glaciers carry cargo. Not politely, not sorted. Everything from fine rock flour to boulders the size of rooms. Some debris rides on top, dropped by slopes and cliffs. Some rides inside, buried by snowfall. Some is pressed into the bottom, dragged like a rasp across bedrock. That dragging is what makes a glacier a sculptor, not just a traveler. It plucks rock from the ground when meltwater freezes into cracks and then pulls blocks loose as the ice moves. It abrades too, grinding surfaces smooth and leaving striations, scratches that point like arrows, showing which way the ice once went. If you ever want to know a vanished glacier's direction, you do not ask the ice. You ask the rock. The rock is still keeping receipts. And glaciers do not only carve valleys, they rearrange whole regions by dumping what they carry. When a glacier pauses, it drops till an unsorted mix of sediment sizes that looks like someone emptied a construction site onto the landscape. When it retreats, it can leave moraines, ridges of debris, marking old ice edges, lines drawn across the land like the glacier's old shoreline. Because that is what a glacier is, in a way, a shoreline of cold. In some places, meltwater streams braid across the outwash plains in front of the ice, splitting and rejoining around gravel bars. The channels change daily because the sediment load is heavy and the slope is shallow. It is a river system that cannot commit to a single answer. You can follow that meltwater too. It carries rock flour that makes lakes look milky blue. A color that feels dreamy until you remember it is ground stone suspended in water. The glacier has been sanding a mountain into drinkable soup. And then the larger consequence arrives, so slowly you could miss it. As the ice builds over thousands of years, it presses down on the crust. The land bends under the load, not cracking like a brittle plate, but sagging like a thick mattress. When the ice melts, the weight lifts, and the land begins to rise again. Isostatic rebound. It sounds like a polite term. It is the planet's posture correcting after a long, heavy sit. The rebound is not quick. The mantle beneath the crust is viscous. It flows slowly back toward the depressed area, so the land can keep lifting for thousands of years after the last ice has gone, which means coastlines can change even without the sea moving much at all. In parts of Scandinavia and Canada, the ground is still rising today. Shorelines become terraces. Old harbors become fields. Boats that once floated in front of a village would now be stranded on land if anyone had forgotten to move them for a few thousand years. Humans love to call something sea level, as if it is one reliable number, but sea level is not a ruler, it is a relationship. Sometimes the water rises, sometimes the land rises, sometimes the land sinks, sometimes all of it happens at once, and you get to argue about which part is real. And even when ice retreats, it leaves behind more than landforms. It leaves behind instability. Valleys, once filled with ice, have steep walls that may collapse. Lakes dammed by ice can drain suddenly when the dam fails. These are called glacial outburst floods, and they are as subtle as a door being kicked in. The calming part, if you want one, is that the glacier does not do it out of anger. It does it because gravity keeps its schedule, and meltwater eventually finds a path. Now, let that cold world fade gently, not into nothing, but into warmth again, because deserts too have their own kind of flow. Not ice flow, not river flow, grain flow. And deserts, like glaciers, love to leave sharp evidence. Wind does not just push dunes around, it can also excavate. If you remove enough loose material, you create a hollow, a deflation basin. The wind keeps stealing fine grains, and the surface drops. Over time, you could end up with a depression that later becomes a playa or even a salt pan if water occasionally visits. That is one of the planet's favorite tricks. Different tools, same shape. A basin can be made by tectonics, by ice, by wind, by dissolution, by a river cutting down. The Earth is not picky. It just wants a low place. In some deserts, wind erosion cuts into soft layered sediments and leaves behind yardangs, long ridges streamlined in the direction of prevailing winds. They look like fleets of stone boats all pointed the same way, as if the landscape is trying to sail. You do not need to measure them. You can feel their logic. Wind accelerates around obstacles. It erodes the upwind side. It scours channels between ridges. It leaves the harder material standing and removes the softer stuff like it was never owed an explanation. The desert becomes a place where hardness is a kind of survival trait. And then there is dust, fine enough to hang in the air, fine enough to cross borders without showing a passport. Dust can dim sunsets. It can paint snow darker, making it melt faster. It can seed clouds. It can carry microbes. It can turn the atmosphere into a long-distance delivery service. If you have ever seen a red sunset and thought it was romantic, it might have been dust scattering the light. Congratulations, you are admiring erosion in the sky. Dust also settles on oceans and feeds plankton in some regions, because plankton need iron, and dust is one way iron arrives. So a desert storm can influence marine food webs, which can influence fish, which can influence birds, which can influence coastal ecosystems. You are not supposed to keep track of all that tonight. Just notice the pattern. One place leaks material into another. The planet is always exporting itself. Now bring your attention back to the Afar Triangle again, because this is where the loop becomes almost easy to see. It is stripped down. The vegetation is sparse. The colors are blunt. The processes are exposed. Afar gives you heat from below and dryness from above, and a crust that keeps cracking because the plates cannot agree to stay together. It is like watching the Earth assemble a new coastline while simultaneously trying to erase the evidence with salt and dust. And if you want to understand why this place feels so dangerous, you can do it with simple stacking. Not one dramatic hazard, many quiet ones layered. Heat first. In extreme heat, your body loses water faster than you notice. The air can feel like it is pulling moisture out of you. Sweat evaporates quickly, which sounds helpful until you realize it means you can dehydrate without ever feeling soaked. And when the ground is hot, it radiates upward, so you are warmed from below and above at the same time. Then, remoteness. Distances here are not friendly. Roads can be rough, and sometimes there are no roads, just tracks. A vehicle breakdown is not a mild inconvenience. It is an event with consequences. Then the geology, not constant catastrophe, but constant potential. Earthquake swarms that come and go, fresh fissures, volcanic gases in low spots. Sometimes the ground is solid basalt. Sometimes it is a crust over mud or brine. The surface keeps switching personalities. And then the human realities. People live here, work here, move through here, because landscapes do not get to choose whether they will host lives. They just exist. And life adapts. The Afar salt trade is one of those adaptations that feels ancient, because it is. Salt was once a kind of currency, a preservative, a necessary. Caravans crossed harsh terrain because salt makes food storable, and storable food makes survival less fragile. Even now, the work continues in forms old and new. Hand-cut slabs in some places, mechanized extraction in others. The desert does not care which method you use. It charges the same heat either way, and in the background, the rift continues its slow pulling. The Nubian plate, the Somalian plate, the Arabian plate, still drifting, still separating, still making space. Space that magma fills, space that basins collect water in, space that might someday invite the sea. That future sea is not guaranteed on a human timeline, but the direction is clear enough to be unsettling. Afar is one of the few places where you can stand on continental crust and realistically imagine it becoming seafloor, not metaphorically. Mechanically, the stretched crust thins, fault blocks drop, volcanism lays down basalt. Over time, if extension continues, you transition from continental rifting to seafloor spreading. Like the Red Sea already does in parts, the middle becomes a spreading center. New oceanic crust forms. The basin deepens. Water moves in. If you want a mental picture, do not think of a sudden split. Think of an old hardcover book whose spine is being slowly forced open. At first, the binding creaks. Then small gaps appear between pages. Then the gap becomes a wedge. Then the wedge becomes a channel. The channel becomes a trough. And eventually, something pours into it. In Afar, that something is likely seawater. Someday, because it is nearby, and because gravity is persuasive. Now, zoom out, not in excitement, but in scale, because the loop you have been following is not just Afar's story. It is Earth's default behavior. Continents tear apart, oceans open, oceans widen. Subduction zones form elsewhere. Oceans close, continents collide, mountains rise, mountains erode. Sediment fills basins, basins get buried. Heat and pressure remake rocks. Some of those rocks melt, magma rises, volcanoes build new crust. It is all one long, unhurried loop. And when you see it that way, certain human worries start to look temporary, not unimportant. Just temporary, because the ground you stand on is also temporary. The coastline you love is temporary. The climate you assume is normal is temporary, not because the planet is cruel, because the planet is active. Now, let the loop touch the simplest, gentlest example again. One grain of sand, one small traveler. You begin as part of a lava flow in Afar, cooling into basalt. Over years, heat and cold crack the surface. Salt crystals pry it wider. A rare rain loosens fragments. A flash flood rolls you into a channel. You settle in a basin and dry into a crust. Wind lifts you on a dry day and hops you across a flat. You join a dune for a while. The dune migrates. Another flood arrives and spreads you across a playa. You dry again. Eventually, you are buried. Time passes. More layers press down. Minerals cement the pores. You become sandstone. Then tectonics shifts. The land uplifts. Erosion exposes you. You weather out again back into loose grains. You do not complete this journey as one continuous event. You do it in chapters, Pause, move, pause, move. That is the planet's rhythm. Long quiet, then transport. Even glaciers follow it. They advance and retreat. They pause at moraines. Then they carve, then vanish. Coastlines do the same. They retreat, then stabilize, then retreat again. Rivers meander, then cut off bends, then meander again. Earth changes like a tired person rearranging in sleep, small shifts that eventually put the whole body in a new position. And if you return again to the Afar Triangle at night, you can feel why it belongs at the start and the center of this story. Because Afar is not just a place where something happened. It is a place where something is happening right now, quietly enough that you can fall asleep beside it. A faint tremor, sometimes. A distant glow, sometimes. A warm rock under your back, salt crunching under a boot. A horizon that feels too flat to be honest. You think you are lying on an ancient, finished continent, but this continent is still deciding what shape it wants to be. The rift does not need your attention to keep working. It will stretch whether you watch it or not. It will thin whether you understand it or not. It will make basins, invite lakes, leave salts, grow volcanoes, and eventually, if the pulling continues long enough, become a new kind of edge, a shoreline that does not exist yet, but is already being prepared. And the strange thing is, how familiar that should feel by now, because you have already followed water, arriving and leaving, and ice grinding and lifting, and wind sorting and carving. You have watched the planet move material from highs to lows, from solid to liquid to solid again. So you can sit with this final idea for a while, without wrapping it up into any lesson, just an observation, as calm as the night air over a salt flat. The Earth is not a collection of places. It is a collection of processes, moving through places the way weather moves through a week. And in Afar, those processes are close to the surface, close enough to feel like a quiet vibration beneath the story. Close enough that if you listen carefully, the desert